This article explains terms used for the British Armed Forces Ordnance and also ammunition. The terms may have slightly different meanings in the military of other countries. BD, between decks, applies to a naval gun mounting in which part of the rotating mass is below the deck, and part of it is above the deck. This allows for a lower profile of turret, meaning that turrets need not be super-firing. BL, the term BL, in its general sense, stood for breech loading, and contrasted with muzzle loading. The shell was loaded via the breech followed by the propellant charge, and the breech mechanism was closed to seal the chamber. Breech loading, in its formal British Ordnance sense, served to identify the gun as the type of rifled breech-loading gun for which the powder charge was loaded in a silk cloth bag, and the breech mechanism was responsible for obturation, i.e., sealing the chamber to prevent escape of the propellant gases. The term BL was first used to refer to the Armstrong breech-loaders, introduced in 1859. Following the discontinuation of Armstrong breech-loaders and the period of British rifled muzzle loaders, British breech-loaders were reintroduced in 1880. At this point the term RBL was retrospectively introduced to refer to the Armstrong breech-loaders, which had a totally different breech mechanism, and since then the term BL has applied exclusively to the type of breech-loader introduced from 1880 onwards using interrupted screw breech. Early British Ellsworth breech-loaders in the 1880s used a steel cup obturation method. This was quickly superseded in guns designed by the Royal Gun Factory by the French Dept method, the basic principle of which is still in use today. In British service this became a crossley pad with an interrupted thread screw block, e.g. a well-on screw. The shell was loaded via the breech, followed by the propellant charge in a cloth bag. A single-use vent-sealing tube, a type of primer not dissimilar in appearance to a blank rifle round, was inserted into the breech for firing the gun. While originally, the term BL contrasted with ML, or muzzleloader, guns, after muzzleloaders were discontinued, the term came to distinguish between traditional non-obturating guns with fabric propellant bags and separately loaded shells, and quick-firing QF guns which used self-sealing brass cartridge cases, and which usually had the propellant and projectile fixed together as a unit for faster handling and loading. For instance, Britain before World War I had both QF and BL 6-inch guns. Both were breech-loading in the general sense, but in the formal nomenclature it separated 6-inch guns with breeches designed for charges in brass cartridge cases from those designed for cloth bag charges. Shells designed for one type were not necessarily suitable for use in the other type. For instance, a BL shell relied upon the tight fit of its driving band in the gun bore to prevent it slipping back when the gun was elevated, but a QF shell could rely upon the cartridge case either fixed or separate to prevent it slipping back. This presented difficulties for BL guns at high angles. A special cartridge was developed for BL 9.2-inch guns on HA mountings, with provision for a wooden stick to be inserted through the center to prevent the shell slipping back on elevation. Although fixed ammunition allows for a rapid rate of fire in small to medium guns, BL is a better choice for heavy caliber guns. Propellant was loaded in a number of small fabric bags, because a single bag holding the full charge would be far too big and bulky for the handlers to lift. Using fabric allows for the charge to be broken into small, easily handled units, while it would be difficult to design a system by which multiple small metallic-cased charged were loaded and fired at the same time. Using multiple small fabric bags also allows the gunners to use a reduced charge if need be. BLC. The term BLC stood for BL converted and referred to a breech and breech mechanism modified modified from an early long screw 3-4 motion to modern short screw single motion. An example is the conversion of the BL 15-pounder to BLC 15-pounder, CR. H caliber radius head, the radius of a circle with the curve of the shell's nose on its circumference, expressed in terms of the shell's caliber. The longer and more pointed the shell's nose, the higher the CRH. Typical CRH for British shells leading up to World War I was 2, e.g. the curve of the nose of a 2 CRH 6-inch shell was equivalent to the curve of a circle with a radius of 12 inches. Shells of 4 CRH were soon developed in World War I, identified by NE following the shell mark number B for 6 and so on. For modern streamlined shells post-World War I, two numbers were necessary to more correctly denote a shell's CRH characteristics. For instance, the World War I 6-inch 2600 weight howitzer shell was 2 CRH. The World War II Mk2D shell was correctly described as 5/10 CRH. Cartridge in British ammunition terminology typically refers to the physical object containing the propellant that a gunner loads. For SAR and fixed QF artillery ammunition e.g. 303 or 18-pounder respectively, this denoted the complete round, i.e. cartridge case, percussion cap, a primer, propellant charge and projectile. In this use it is synonymous with round. For separate QF artillery, cartridge referred to the cartridge case, its primer, propellant charge, and the disposable lid and fastener of the case. In BL artillery terminology, cartridge referred to the propellant unit only. There was no case. British cartridges up to approximately 1892 contained gunpowder, and thereafter sticks of cordite bound up together with an igniter pad if necessary. In a cloth bag, usually silk, the stick nature of cordite gave the cartridges a degree of rigidity and hence they retained a tubular shape and could be handled and loaded as a solid unit even without a case. With BL, cordite is contained in one or more cloth bags joined together. The complete unit is termed a cartridge. The empty bag was termed an empty cartridge. Heavy naval guns may require up to 4 separate cartridges to be loaded, each consisting of a 1/4 charge to make up the full service charge. Howitzer cartridges, both BL and separate QF, contained a central core of cordite surrounded by several stacked bags in the shape of rings, containing cordite. To obtain the appropriate charge for the required range and angle of elevation, the gunner removed and discarded one or more rings before loading. See charge for how QF 25-pounder charges were varied in World War II. Cartridge case. The case, usually brass, holding the propellant charge, used with small arms and QF artillery ammunition. The QF cases in 1915 could be cleaned and then reloaded up to a maximum of 6 firings with cordite charges, with the record detailing the life of the case marked on the base. The limitation on the number of firings was due to the case expanding on firing, having to be rectified by turning metal off the lower part, which restored the correct dimensions but progressively weakened the case. Charge was a concept, a category label rather than a specific item. It can be described as the standard amount of propellant specified to carry out a particular purpose. Full service charge. The full amount of propellant intended for use in action at maximum range, for the usual shell. If a gun had e.g. a heavy and a light shell, there would be a separate charge associated with the heavy and light shells. Reduced service charge. For practice of firing star shells. Proof charge. A charge giving 25% greater chamber pressure than the full service charge, intended only for the proof or testing of a gun. Blank charge, intended for firing without a projectile, usually a reduced charge. battering charge, especially large charge for use with palliser projectiles, which were an early British armor-piercing projectile of the mid to late 19th century. For practical purposes, specific cartridges were specified for use to obtain the required charge. A gunner dealt with cartridges and would know that he could load cartridge X or Y for a full service charge for his gun, and cartridge Z to fire a star shell. Cartridges were sometimes made up of fractions of charges, e.g. a 6-inch gun cartridge may be made up of 2 by 1/2 charges, a 1 by 2/5 and 1 by 3/5 charge laced together. A gun normally fired all rounds using the full charge, and varied the range by elevating or depressing the barrel. A howitzer gunner's job was more complicated because the range table would specify different charges, or fractions of the full service charge, for different ranges and angles of shell descent. The standard cartridge for his gun, which as a whole made up the full service charge, would consist of a central mushroom cordite core and several smaller cordite rings in bags stacked around the core like donuts, all tied together. It was designed so that one or more rings could be quickly removed and discarded before loading, hence providing progressively smaller charges. E.g., if the gunner on a QF 4.5-inch howitzer was ordered to load charge 4, he would know he had to remove the top ring from the cartridge, leaving 4 rings. For charge 3, he would remove 2 rings. Discarded rings were burned after the action. This was the standard procedure for howitzers up to and including World War II. In World War II, a different system was introduced for varying charges for the QF 25-pounder gun howitzer, which used separate loading QF ammunition. A separate 2.7 pounds supercharged cartridge was available for firing the 20-pound high-velocity anti-tank cap shot, and an additional 4.5 ounces supercharge increment could be added to that for even higher velocity. The cartridge for firing the standard 25-pound shell came ready loaded with a red bag at the bottom containing the basic charge, together with white and blue bags laid lengthwise, as in a conventional gun charge, to make up the full service charge. The blue and white bags could be removed to provide progressively reduced charges. From 1944, 1 or 2 4-ounces intermediate charge increments could be added to the standard charge for high-angle fire and to provide greater control over angle of shell descent. For small arms or fixed QF ammunition, where the charge could not be varied by the gunner, the term charge was used to identify the cordite propellant within the cartridge case, and the round as a whole was referred to as a fully reduced charge. E.g., an 18-pounder star round consisted of a cartridge case containing a reduced charge and an attached star shell. Common lyddite. British explosive shells filled with lyddite were initially designated common lyddite, and beginning in 1896 were the first British generation of modern high-explosive shells. Lyddite is picric acid fused at 280 degrees Fahrenheit and allowed to solidify, producing a much denser dark yellow form which is not affected by moisture and is easier to detonate than the liquid form. Its French equivalent was melinite, Japanese equivalent was chamois. Common lyddite shells detonated and fragmented into small pieces in all directions, with no incendiary effect. For maximum destructive effect, the explosion needed to be delayed until the shell had penetrated its target. Early shells had walls of the same thickness for the whole length. Later shells had walls thicker at the base and thinning towards the nose. This was found to give greater strength and provide more space for explosive. Later shells had 4C-R heads, more pointed and hence streamlined than earlier 2C-R-H designs. Proper detonation of a lyddite shell would show black to gray smoke, or white from the steam of a water detonation. Yellow smoke indicated simple explosion rather than detonation, and failure to reliably detonate was a problem with lyddite, especially in its earlier usage. To improve the detonation, exploders with a small quantity of picric powder or even of TNT was loaded between the fuse and the main lyddite filling, or in a thin tube running through most of the shell's length. Lyddite presented a major safety problem because it reacted dangerously with metal bases. This required that the interior of shells had to be varnished, the exterior had to be painted with leadless paint, and the fuse hole had to be made of a leadless alloy. Fuses containing any lead could not be used with it. When World War I began, Britain was replacing lyddite with modern, high-explosive, such as TNT. After World War I, the term common lyddite was dropped, and remaining stocks of lyddite-filled shells were referred to as he-shell-filled lyddite. Hence, common faded from use, replaced by he as the explosive shell designation. Common lyddite shells in British service were painted yellow, with a red ring behind the nose to indicate the shell had been filled. For shellite, US successor of lyddite, see he below. Common pointed shells, or CP, were a type of common shell used in naval service from the 1890s-1910s, which had a solid nose and a percussion fuse in the base rather than the common shell's nose fuse. The ogival 2C RH solid pointed nose was considered suitable for attacking shipping but was not armor-piercing. The main function was still explosive. They were of caster-forged steel and contained a gunpowder bursting charge slightly smaller than that of a common shell, a trade-off from the longer, heavier nose. In British service, common pointed shells were typically painted black, except 12-pounder shells specific for QF guns, which were painted lead color to distinguish them from 12-pounder shells usable with both BL and QF guns. A red ring behind the nose indicated the shell was filled. By World War II, they were superseded in Royal Navy service by common pointed capped and semi-armor piercing, filled with TNT. Common shell designated early British explosive shells filled with low explosives, such as P mixture, and usually with fuses in the nose. Common shells on bursting tended to break into relatively large fragments which continued along the shell's trajectory rather than laterally. They had some incendiary effect. In the late 19th century, double common shells were developed, lengthened so as to approach twice the standard shell weight, to carry more powder and hence increase explosive effect. They suffered from instability in flight and low velocity and were not widely used. As at 1914, common shells 6-inch and up were of cast steel. Smaller shells were of forged steel for service and cast iron for practice. They were replaced by common lyddite shells in the late 1890s, but some stocks remained as late as 1914. In British service, common shells were typically painted black with a red band behind the nose to indicate the shell was filled. CP, central pivot, was applied to a naval gun mounting that rotates around a central pivot that could be bolted to the deck without any structural alterations being required. CWT. The abbreviation CWT stands for hundredweight, which, despite the name, is equal to 112 pounds, and signifies the weight of the gun barrel and breech. It is sometimes included in the name of a gun to differentiate it from other guns of the same caliber or weight of shot. For example, the QF 12-pounder 1800 weight naval gun is a different weapon than the QF 12-pounder 8 CWT-MKI naval gun, though they both fire shells of the same approximate weight. DCT, the director-control tower, was a feature of naval ships. It was a trainable turret incorporating the gun-laying sights and often a rangefinder. From here, the gunnery officer could select targets targets and take the range, bearing and rates of change. This data would be provided to the transmitting station, where a firing solution would be calculated and passed on to the gun turrets as the correct degree of training and elevation. Effective full charge. Gun barrels naturally experience internal wear when fired, caused by mechanical wear from the projectile moving along the barrel, and thermal and chemical wear from propellant gases. This wear can reduce muzzle velocity, enhance range, affect accuracy, produce unstable projectile flight, and, eventually, cause the gun barrel to fail. Most guns are capable of firing different types of ammunition with varying charges, and not all of these combinations produce the same firing damage per round fired. The concept of effective full charge provides a means of estimating the remaining life of a gun barrel, taking into account the varying charges that can be fired from it before it becomes so worn as to be unusable, or no longer safe. To illustrate, the round that produces the most firing damage is assigned an effective full charge value of 1. Other round combinations are assigned lesser values derived from testing and experience. If a gun barrel is capable of firing 3 different round types, round A, round B, and round C, and if 100 of each round type is fired, then the barrel is said to have fired += 200 EFCs. If it had previously been determined from testing and experience that this type of barrel has an estimated wear life of 250 EFCs, this specific barrel is at about 80% of its useful life. Plans would be made to order a replacement barrel within the time an additional 50 EFCs were expected to be fired. However, the actual decision to retire any specific barrel would be made on examination and measurement of actual wear rather than the predicted by the EFC count. In practice, a barrel might be replaced before reaching its EFC life, or the limits of wear. In the case of the 15-inch guns fitted to the WW1 Marshall Ney class monitors, a gun was generally condemned when wear reached about 0.74 inches at 1 inch from the start of the rifling. However, it was the usual practice to replace guns when the projected remaining life fell below the ship's normal full outfit of ammunition per gun, which ensured that the entire magazine could be safely fired in action. Equipment. This was the term used to describe a gun together with its carriage, i.e., the complete set of equipment needed to be able to fire the gun, as the gun could only be fired when mounted on its correct carriage. The carriage could be a wheeled carriage, a static siege carriage, or include both a traversing mounting and railway wagon in the case of a railway gun. For example, a complete deployable gun might be described as Ordnance QF-18PDR gun Mk2 on carriage field QF-18PDR gun Mki. Gunpowder. Britain employed gunpowder as a propellant until superseded by cordite Mki from 1892, and as an explosive filling in common shells until slowly superseded by lyddite from the late 1890s. In World War I, gunpowder was still in wide British use, in shrapnel shells as a burster to propel the bullets out of the case, in igniter pads at the ends of cordite cartridges to facilitate ignition, as the delay mechanism in time fuses for artillery, in vent tubes for firing guns. British gunpowder designations were EXE extra experimental propellant mixture of 2/3 brown and 1/3 black powders used with BL 6-inch guns MK3 IV and AMP-I. LG large grain propellant. Mealed powder, powder in fine dust form, used to ignite fuses, friction tubes. Prism are molded powders, propellant pressed into regular hexagonal prism shape, with a hole in the center to give even burning, included prism brown and prism black. P. Pebble powder, propellant in cube shape, designed to reduce the ratio of surface area to weight, and hence to slow the rate of burning to reduce strain on guns. A larger weight of P is required than R. Lg for an equivalent charge. SP. Propellant, P specially selected for consistency, for use in BL guns. P. Mixture of pebble and fine grain powders, explosive, filled common and common pointed shells. QF. Mixture, explosive, filled medium-sized common and common pointed shells. RFG squared, rifle fine grain, dogwood charred for 8 hours, bursting charge for shrapnel and star shells. RLG, rifle large grain, propellant, explosive filling for armor-piercing shells. SBC slow burning cocoa, propellant, brown powder. Gas check, attached to the base of RML artillery shells from 1878 onwards to avoid gas wastage on firing, and to rotate studless shells. It was an interim measure between studs and modern driving bans. Related terms: attached gas check used with studded ammunition. Automatic gas check used with studless ammunition. Rotating gas check, synonymous with automatic gas check. High angle, a naval designation equivalent to AA for a gun mounting which was capable of an elevation exceeding 50 degrees from the horizontal, allowing the gun to be used against aircraft. LA, high angle, low angle, a naval designation equivalent to dual purpose for a weapon intended for engaging both surface targets and aircraft, on a mounting capable of elevating above 50 degrees but also effective at low elevations. Typical examples were the QF 4-inch Mk16, QF 5.25-inch gun and QF 4.5-inch gun used in World War II and later.